In this video, L will explain all commands and tools you need to manage network service and IP addresses on Linux in RHCSA or RHCE Exam. First, I will explain the terminology Linux uses for network devices and their configuration files. Later, I will show you how to manage and edit network configuration files. Finally, I will explain all commands and tools you need to view, list, and manage IP addresses. I will explain each command and tool through various examples. LAN cards, network adapters, or network interface cards are hardware adapters that provide one or more Ethernet ports. An Ethernet port is called a network device or a network interface. A network interface uses a connection to connect the network. A connection is a collection of all settings the interface needs to connect to the network. IP configuration, hardware address, boot state, and device name are some examples of the settings the connection includes. You can assign multiple connections to an interface but can use only one connection at a time. To assign multiple connections, you need to use a unique name for each connection. You can also configure the interface to automatically select the appropriate connection. Starting from RHCSA, the UDEV-D service provides the default naming scheme for network interfaces. This service usages many rule sets to assign a unique name to each interface. To generate a unique name for an interface, it uses the device firmware, location, topology, and type. In generated name, the first two letters represent the device's firmware. For example, Ethernet interfaces begin with EN, VLAN interfaces begin with WL, and WAN interfaces begin with WW. The next letter represents the device's type, location, or topology. For example, the letter O represents an onboard device, the letter S represents a hot plug slot, and the letter P represents a PCI card. The remaining numbers represent an index, ID, or port. Let's take an example name ENO167777737. In this name, the first two letters EN stand for an Ethernet interface. The next letter O stands for an onboard interface. The remaining number 167777737 is a unique ID number. Linux stores every connection as an interface configuration file in the /etc/sysconfig/network scripts directory. An interface configuration file controls an individual network device. As the system boots, it uses interface configuration files to determine what interfaces to bring up and how to configure them. The name of a configuration file starts with ifcfg and is followed by the name of the network interface or connection. By default, the system automatically generates connection configuration files for all detected devices. If the system generates a connection configuration file, it uses the name of the interface after the ifcfg prefix. As I mentioned earlier, an interface can have multiple connections. There are multiple ways to add new connections to an interface. You can add them manually or can use a network manager tool. We will discuss network manager tools later in this video. This is the name of the connection. Network Manager will use this name as the suffix to generate the file name. To verify it, we can list all connection files again. If you manually add a connection, you can use any descriptive name for the connection. A connection includes many settings. To view a complete list of all settings and a detailed description of each setting, you can use this command. You don't need to learn or understand all these settings for RHCSA or RHCE Exam. For RHCSA or RHCE Exam, you only need to create a simple connection file with essential settings. To create a simple connection file for testing, you need to understand 7 settings. These settings are name, type, device, on boot, boot proto, IPADDR, and netmask. Let's create a simple connection file to understand these settings. You can use any text editor to create a connection file. This is the name of the connection. Network Manager will attach this name as the suffix with the ifcfg prefix to generate the connection file name. This name will also be used for listing and managing this connection. This is the type of interface for which we are creating this connection. This setting links this connection to a physical device. You can create a connection without linking it to any physical device, but in that case, you cannot use it. This setting allows us to specify the action the system should take at the boot time. If we set the value to yes, the system will start this interface at boot time. If we set the value to no, the system will not start this interface at boot time. This setting defines the boot time protocol. You can configure 3 values for this setting. These values are none, boot P, and DHCP. If you use the value none, the system will not use any protocol at boot time to obtain an IP configuration. If you want to assign a static IP address to this connection, you should use this option. If you use the value boot P, the system will use the boot P protocol to obtain an IP configuration at the boot time. If you want this connection receives an IP configuration from a DHCP server, use the DHCP value here. We will manually assign an IP address to this connection. For this, specify the value none here. This setting allows us to specify an IP4 address. Linux allows us to configure multiple IP addresses for a single interface in the same connection file. To configure multiple IP addresses, use consecutive positive integers starting from 0 with the setting. This setting configures the subnet mask of the IP address. If you are adding multiple IP addresses, you need to add a separate subnet mask for each address. To add multiple subnet masks, use consecutive positive integers starting from 0. You need to use numbers only if you are adding multiple IP addresses. If you are adding only one IP address, you can omit it. Let's save the file. Network Manager does not actively monitor connection files. To force it to reread all connection files, we use this command. After this, we can use this command to list all connections. As we can see here, the ENS160 interface is currently using the default connection file. To instruct the interface to use our connection file, we need to activate our connection file. We will discuss these commands later in this video. As we can see here, now the interface is using our connection file. We can also check the IP configuration of this device. Here is the IP address that we configured. To delete a connection file, activate the default connection file again. Use the rm command to delete the file. To confirm the delete operation, type Y and press the Enter key. Use the same command again to delete the file that we added manually. Reload all connections to force Network Manager to reread all connections files. To verify the delete operation, we can list all connections again. As we can see here, all deleted connections have been removed. We can also list the network scripts directory to confirm that all deleted connections files have been removed. The IP utility provides the IP command. The IP command allows you to manage and monitor many aspects of networking. It makes changes only in the running configuration. It does not save the changes. When you reboot the system or log out from the current session, all changes made by the IP command will be lost. The IP command supports command line abbreviation. You don't need to type the complete option. You only need to type the letters for the option until it becomes unique. For example, you can use the command IP address show, or can use this command. Both commands will return the same output. To view the IP configuration of all interfaces, we use the IP address show command. To view the IP configuration of a single interface, we need to specify the name of that interface. For example, let's check the IP configuration of this interface. This is the link state of the interface. This is the MAC address of the interface. This is the IPv4 address of the interface. This is the IPv6 address of the interface. You can also assign a new IP address to the interface. To assign a new IP address, we use the add and dev options with the IP address command. Let's assign a new IP address to this interface. This is the new IP address. This is the name of the interface to which you want to assign the IP address. To verify the new IP configuration, you can use the IP address show command again with the interface name. We can assign multiple IP addresses to the same interface. Let's assign 2 more IP addresses. These IP addresses will not persist across the reboot. When you will reboot the system, these addresses will be removed. Let's reboot the system and check the IP configuration of this device again. Use the IP address show command to list the current configuration of the interface. As we can see, all IP addresses that we assigned to this interface are gone. A network interface can connect to the network only if its link state is up. The IP address show command prints all configuration of the interface. If you only want to view the link state of the interface, you can use the IP link show command. This command prints only the link state information of the interface. If you don't specify an interface name, it will print the link state information of all interfaces. To view the link state information of a single interface, we need to specify the name of the interface. For example, let's check the link state information of this interface. For testing or troubleshooting, we can also temporarily change the link state of an interface. To bring it down, we use this command. To bring it up, we use this command. Just like the IP addresses, the link state information will reset to default when you will reboot the system. The default gateway connects the system to the remote network. To view the default gateway IP, we use the IP route command. This command prints all route entries from the routing table. This is the IP address of the default gateway. Arp Neighbor Table maintains information about the nodes available on the local network. To view this table's entries, we use this command. The system maintains a separate Arp Neighbor Table for each interface. To view the Arp Neighbor Table of a specific interface, we need to specify the name of the interface. You don't need to remember any option of the IP command. You can use the help option to get detailed information about all options. For example, to get information about the address option, we use the help option with the IP address command. Let's get help about the link option. If you need more information or some examples of usages, you can use the man IP command. This command prints the manual document of the IP command. It contains all options, their description, and sample usages. The IP command is a replacement for the ifconfig command. In earlier versions of Linux, the ifconfig command was the default utility for checking and verifying IP configuration. The ifconfig command does not support many modern features that were not relevant in earlier times. The ifconfig command is deprecated. Although RHEL still includes the ifconfig command for backward compatibility, you should use the IP command for all IP validation and verification related tasks. The IP command is designed to meet the requirements of modern networks. The IP command can perform all tasks of the ifconfig command. For example, let's perform some common tasks of the ifconfig command with the IP command. To print the IP configuration of all interfaces, we use the ifconfig command. We can do the same task with the IP address show command. As you can see, both commands print the same output. We can also specify the interface name with both commands to view the IP configuration of a specific device. Let's do the same task with the IP command. Again, we get the same output. To change the state of an interface, we use the up and down option with both commands. Let's use these options first with the ifconfig command. Now, use these options with the IP command. To assign a temporary IP address with the ifconfig command, we need to use the command 2 times. The first time, we will assign the IP address. The second time, we will assign the subnet mask. With the IP command, we can assign the IP address and subnet mask at once. Linux uses various daemon processes to control and manage its services. Network Manager is a network control and configuration daemon. Starting from RHCSA, it provides the default networking service on Red Hat Linux. It dynamically controls all networking devices and their connections. It keeps them up and active when they are available. It offers various tools and commands to configure and manage them. Using Network Manager makes network management easier. If Network Manager detects a network device without a connection, it automatically creates a temporary connection and attaches it to the network device. Let's understand it through the example. Currently, this system has one Ethernet card. If we attach one more Ethernet card to it, Network Manager will automatically create a temporary connection and attach it to the Ethernet card. To attach a new Ethernet card, shut down the system. Click Edit Virtual Machine Settings. Select Network Adapter and click Add. Select Network Adapter and click Finish. Click OK. Now power on the virtual machine again. Log in from the root user. Open Terminal. List all interfaces again. This is the new interface that we added recently. As you can see here, it automatically got a connection profile. Can you guess where this connection profile came from? When we start the system, the UDEV-D service scans all network slots and assigns a unique name to each interface, and reports all detected network interfaces to Network Manager. Network Manager checks all interfaces. If it finds an interface without a connection, it creates a temporary connection and attaches to it. This practice ensures that the system can use the new interface as soon as you attach it to the system. The next advantage of using Network Manager is that it includes various tools that allow us to configure and manage connections easily. It allows us to configure IP addresses, default gateway, static routes, network aliases, DNS information, VPN connections, and many other connection-specific parameters. It also offers an API through Dbus. Applications can use the API to query and control network configuration and state. For example, the RHEL web console, which monitors and configures servers through a web browser, uses the Network Manager Dbus interface to configure networking. Network Manager can also save and maintain the state of devices after the reboot process. To save the state of an interface, it uses configuration files. Let's take an example. Suppose you don't want to start this interface at the boot time. For this, you can use a Network Manager's tool called Nmcli to change the boot state. Currently, the value of the on-boot directive is set to yes. If we set it to no, the boot process will not start this interface when the system boots. Let's restart the system. Log in again from the root account. Here you can see that the boot process did not start this interface. The systemctl command lists and manages the state of services. It supports many options. Some important options are status, start, stop, enable, and disable. Let's take some examples to understand how to use these options to manage the Network Manager service. To view or check the current status of Network Manager, we use the status option. In the output, if we see active here, it means the service is up and running. Or if we see inactive here, it means the service is down and not running. To stop the Network Manager service in the current session, we use the stop option. To start it again, we will use the Start option. The Start and Stop options start and stop the Network Manager service in the current session only. If we want to start or stop it at the boot time, we need to use the Enable and Disable options. To disable it at the boot time, use the Disable option. The boot process uses a list of script files to start services. This command removes the script files that start the Network Manager service from the list. To add them again, we will use the Enable option. This command will add the script files again to the list of the boot process. There are 5 commands and utilities that you can use to connect to Network Manager. These are Nmcli, Nmt Ui, Control Center, Nmconnection Editor, and Network Connection Icon. From these, Nmcli, Nmt Ui, and Nmconnection Editor are the part of Network Manager package. Control Center and Network Connection Icon are offered by GNOME Desktop package. Let's discuss these commands and utilities in detail. Nmcli is the main command of Network Manager. It can control and configure all aspects of network devices and connections. It does not need a GUI environment to run. Generally, administrators do not install a GUI environment on Linux servers. If GUI is not installed, you can use it to manage and configure all network devices and their connections. It runs on all platforms and supports all features and functions of Network Manager. Network Manager offers the Nmt Ui utility to users who don't like to use a command to manage network devices. It provides a curses-based text user interface for Network Manager. It runs on the command line and desktop. It does not work on a remote connection. It supports all important features of Network Manager that you need to configure and manage network devices and their connections. If you find working with the command line a bit difficult, you can use this utility to configure network devices. The Nmconnection Editor. Network Manager offers this utility for desktop users. It looks similar to the Nmt Ui utility but supports fewer features than the Nmt Ui utility. You can use this utility only on the GNOME desktop. You cannot use this utility on CLI command prompt. We will discuss the differences between the Nmt Ui utility and the Nmconnection Editor utility in detail later in this video. GNOME Desktop Package also offers 2 tools to work with the Network Manager. These tools are the Network Control Center and Network Connection Icon. Both tools use Network Manager's API to manage and display the current state of network devices. To start the Network Control Center, type Network here, and click Network. It is also known as Network Settings tool. From here, you can manage all essential network settings. GNOME also displays the current status of all detected network interfaces here. You can perform some basic tasks directly from here, such as viewing the current status of an interface and connecting or disconnecting an interface. To open this interface's setting in the Network Control Center, click here. The Network Control Center and Network Icon both are the part of GNOME Desktop package. They will be available if you install the GNOME Desktop. Let's summarize all 5 utilities once again. The Nmcli command runs on all platforms. It is complex but supports all features of Network Manager. The Nmt Ui utility runs on both CLI and GUI. It supports all necessary features of Network Manager. The Nmconnection Editor is similar to Nmt Ui but runs only on GUI. Network Control Center runs only on the desktop. It supports all essential features of Network Manager. The Network Connection Icon is also available only on the GUI. It supports only basic features. The Nmcli command is one of the most complex commands on Linux. Learning and using this command is not an easy task if you don't know how to use manual pages. But if you know how to use manual pages, then using this command is not a difficult task for you. The manual pages for this command include everything you need to learn and use this command. To open the manual pages, use this command. The Nmcli command usages this syntax. It has 3 parts: option, section, and action. Options are optional. They allow us to control the default behavior of the command. You can use them to modify the output in such a way that it only displays the required information in the desired format. To use the Nmcli command, you don't need to memorize any option. All options of the Nmcli command are described here. If you want to know which option does what or which option you should use to get the desired result, you can use the manual pages. After the option, the syntax has the section. The Nmcli command organizes its parameters into 8 sections. These sections are Help, General, Networking, Radio, Connection, Device, Agent, and Monitor. These sections provide hundreds of options and parameters to control various accepts of networking. Based on your requirement, you can use any section. For RHCSA or RHCE Exam, we only need to focus on the device and connection sections. The device section includes parameters to control and manage network devices, while the connection section includes parameters to create, control and manage connections. For RHCSA or RHCE Exam, we need to learn how to check the current status of network devices and manage their connections. This manual page includes all the necessary commands for these requirements. If you need more examples or want to work with other sections, you can check the additional manual, which includes many advanced examples. To view these examples, you can use this command. As you can see here, it includes many sample commands with output. You can pick and use any command that meets your requirement. These manuals include many examples and detailed descriptions of each option and parameter. If you have these manuals, you do not need to memorize anything to use the Nmcli command. Since we only need to work with the device and connection sections, we don't need these advanced examples. Let's close this example manual and use the main manual to practice our exam topics. The Nmcli command is part of the Network Manager package. Network Manager provides the default network service on Linux. To know whether the Network Manager service is running or not, we can use this command. As we can see here, the Network Manager service is running. On Linux, the systemctl service controls other services. Let's stop the Network Manager service and check again. As we can see here, the Network Manager service is not running now. Let's start the service and check the status again. You can also use this command to check the overall status of the Network Manager service. If the Network Manager service is running, we can use the Nmcli command to manage network devices. To check the current status of network devices, we use this command. This is the device name. This is the type of device. This is the current status of the device. This is the name of the connection this device is currently using to connect the network. In short, the device ENS160 is using the connection ENS160 to connect the network. The type of the device is Ethernet and it is currently connected to the network. The manual page includes many other examples with detailed descriptions for the device section. We don't need them for RHCSA or RHCE Exam. If you want to manage or change the state of a device, you can use them. Now let's move to our main section. For RHCSA or RHCE Exam, you mainly need to focus on the connection section. As mentioned earlier, a connection is a collection of settings that an interface uses to connect to the network. An interface can have multiple connections but can use only one connection at a time. For RHCSA or RHCE Exam, we need to learn how to add new connections and manage existing connections. To view a list of all connections, we use the Show option with the Nmcli connection command. In the output, This is the name of the connection. This is the unique ID of the connection. This is the type of interface for which this connection can be used. This is the name of the interface which is currently using this connection. By default, this command lists all connections. To view a list of only active connections, use the Active option. To view all settings of a connection, we need to specify the name of the connection. These are the configuration directives or settings. These are the configured values. There is a long list of settings. We don't need to learn or remember all of these. We only need to understand and learn a few important settings. We will discuss them later in this video. Just like the commands that we have discussed, the manual page includes an example command for every topic that we need to practice for the RHCSA or RHCE exam. For RHCSA or RHCE exam, you don't need to memorize any option or parameter of the Nmcli command. All you need to do is open the manual page of the Nmcli command, pick the example command, change the name of the connection or device and use it. Let's add and manage a new connection by using the examples given on the manual page. To explain this exercise, I need more workspace. For this, I am closing this terminal. All commands of this exercise are available on the manual page. To add a new connection, we use the Add option. After the Add option, we need to specify a name for the connection. After the name, specify the type and name of the interface. Finally, if you want to configure any connection setting, you can do it here. Let's set the IP configuration method to auto. This command creates a new connection named ETH1 and assigns the connection to the ETH1 interface. This connection will receive an IP address from the DHCP server. To verify the connection, we can list all connections again. When we add a new connection, the Nmcli command creates a new file in the network script directory. It uses the connection name as the file name with the ifcfg prefix. It saves all configuration settings in this file. There are multiple ways to edit a connection configuration file. You can directly edit it by using a text editor or can use a network management tool. You can also use the Nmcli command to edit this file. To update this file by using the Nmcli command, we use the Modify option. This command changes the IP configuration type to manual from DHCP, assigns IP address 10.0.0.10. And sets the default gateway to 10.0.0.1. To verify the change, we can view the configuration file again. As we can see here, the file has been updated. You can also view and change the value of a single directive. To view the value of a single directive, we use the egrep command. As we can see here, the current status of the onBoot directive is set to yes. The onBoot directive controls the boot time behavior of the connection. The boot process will start this connection at the boot time only if you set its value to yes. The name of this directive in the setting is connection.autoconnect. Set it to no. Let's print the setting again. Here we can see, the value of the directive has been updated. The Nmcli command also offers an interactive editor to edit a connection. To use this editor, specify the connection name after the edit option. You can use the help option to list all available options and their usage. To print the configured value of a directive, use the print option. To change the value of a directive, use the set option. To save the change, use the save option. Use the quit option to exit. You can also view the connection file to verify the changes. As I mentioned earlier, an interface can have multiple connections but can use only one connection at a time. It uses only the active connection. To set a connection active, use the up option. When activating a connection, you may get this error. Connection activation failed. No suitable device was found for this connection. This error indicates that we are activating a connection that was created for an interface that is not available on the system. We can fix this error by updating the interface name in the connection setting. To view all configured settings of a connection, we use the show option. We can use the grep command to filter the output and view only the name of the interface. To update the name, we can use the modify option. Let's verify the change. Now, activate the connection again. When we activate a new connection, the existing connection becomes inactive. As we can see here, the ENS160 interface is using this connection now. Let's activate the default connection again. To view only active connections, we can use the active option. An interface reads the connection file only when it starts. It does not monitor the changes to the connection file. If you make any change to a connection file, you need to update the interface about the change manually. For example, currently, this interface is using the IP address 192.168.0.100. Let's check which connection this interface is using. As we can see here, this interface is using the ENS160 connection. Now, update the IP address of this connection. Verify the change. As we can see here, the IP address has been changed on the connection configuration file. Now, check the configured IP address on the interface again. As we can see here, the interface is still using the old IP address. An interface does not monitor the changes to the connection file. It reads the connection file only once. To force an interface to use the updated connection file, we need to remove the current connection from the interface. To remove an active connection, we use the down option. After removing the current connection, we need to attach the updated connection again. To attach a new or updated connection, we use the up command. Now, check the IP address again. As we can see here, now the interface is using the new IP address. You can also delete unnecessary connections. To delete a connection, we use the delete option. Let's delete this connection. Use the delete option and specify the connection name. List all connections again. As we can see here, the connection has been deleted. The Nmt Ui utility provides a curses-based application for managing network devices and connections. We can use this utility from a terminal on the desktop and from the command prompt on the CLI interface. To start this utility on the desktop, open a terminal. Run this command. This utility does not need a GUI environment to run. It means you can also use this utility on a CLI interface. Administrators usually do not install graphic environments on servers. If you have a desktop-less server and want to manage network devices and connections in a desktop-like environment, you can use this utility. On this system, we have the GUI environment. Let's switch back to GUI. No matter whether you use this utility with or without a GUI environment, it works similarly. On the first screen of this utility, we have three options. This option allows us to add a new connection and manage existing connections. This option allows us to activate or deactivate a connection on an interface. This option allows us to change or set the system host name. To move between the options, we can use the tab key or arrow keys. Each option has a subscreen that allows us to configure the option. To access the subscreen of the option, select the option and press Enter key. The Nmt Ui utility also offers a command to directly access the subscreen of each option. We can access the subscreen of the first option by using this command. As we can see here, both screens have the same options to add and manage connections. From here, we can add a new connection and update existing connections. Let's close this screen and move to the second option. To access the subscreen of the second option, we will use this command. Press Enter key to access the subscreen. Again, we get the same options on both screens. Now, let's move to the third option. We will use this command to access the subscreen of the third option. No matter whether you use the first screen of the Nmt Ui utility or the related command to access the subscreen of an option, the settings available on the subscreen are the same. These commands are only used to bypass the first screen of the Nmt Ui command. From the subscreen of an option, we can manage all option-related settings. Let's create a new connection and activate it on the Ethernet interface. To add a new connection, select the first option and press the Enter key. On this screen, the left side displays all existing interfaces and their connections. The right side displays options to manage the selected connection. To manage an existing connection, first, we need to select it from the left side. To add a new connection, we will use the Add option. Here, we need to select the network interface for which we are creating this connection. This list includes many types of network interfaces. You can create a connection for any type of network interface. But you can use that connection only if that interface exists on the system. For example, if you select Ethernet here, you can use this connection only if the system has an Ethernet card. This system has one Ethernet card. You can create multiple connections for a single Ethernet card but can use only one connection at a time. Let's create a new Ethernet connection. The next screen allows us to customize the connection. This is the name of this connection. This is the device type. If you want to update the device type, you can do it from here. To assign an IP address manually, set IP4 configuration to manual. Now, configure the IP4 address to 10.0.0.10. Set default gateway to 10.0.0.1. If you keep this option selected, the network device will automatically use this connection to connect to the available network. This option is useful when your system has a wireless LAN card and you use the system in different locations. You can create multiple connections. You can create one connection for each location. On each connection, you can keep this option selected. If this option is selected on multiple connections, the wireless LAN card automatically selects the appropriate connection to connect to the network. In the lab environment, we don't need it. Uncheck this option. This option allows all users to use this connection. Keep it selected. After updating all settings, select OK, and press Enter key. The Nmt Ui utility creates a new connection with specified settings and adds it to the list of connections. By default, it does not activate the new Ethernet connection. To use this connection, we have to manually activate it. We can activate it from the first screen of the utility. Select Back and press Enter key. On the first screen, select the second option and hit the Enter key. Select the recently added connection and activate it. Wait for a few seconds. The utility activates the connection. It shows a star before the active connection. As we can see here, now this connection is active. Let's move back to the first screen. So far, we have added a new connection and have made the new connection active. Now, let's change the host name. To change the host name, we will use this option. Update the host name. Confirm the change and move back to the first screen. To close this utility, use the Quit option. To verify the new connection, we can use the Nmcli connection show command. This command lists all connections and their current state. As we can see here, this interface is now using the connection that we added recently. We can also use the active option to see only the active connections. To verify the IP configuration, we can use the IP address show command. As we can see here, the connection is using the configured IP address. Finally, to verify the host name, we can use the hostname command. Here is the updated host name. The default command prompt also includes the host name. It will update when we will restart the terminal. As you can see here, the hostname has been updated. Now, delete the connection that we added recently. For this, open the Nmt Ui utility again, select Edit a connection, and press Enter key. Select the connection you want to delete from the left side and move to the Delete option. Press Enter key to delete the selected connection. Confirm the delete operation. Quit from the Nmt Ui utility. To verify the delete operation, we can use the Nmcli connection show command again. As we can see here, the connection has been deleted. Nmconnection Editor is a GUI-based application. To start this application, we use the Nmconnection Editor command. We can use this command only on the desktop environment. To confirm it, let's switch to the CLI interface and use this command. As we can see here, the command is not running. It verifies that this command does not work on CLI and needs a GUI environment to run. Let's switch back to GUI. The Nmcli utility uses the CLI interface. It works on all platforms. You can use it on SSH, terminal, and desktop. It supports all features of the Network Manager. The Nmt Ui usage is a curses-based application. It works on the terminal and desktop. It supports all necessary features of the Network Manager. The Nmconnection Editor usage is a GUI-based application. It works only on the desktop. It is similar to the Nmt Ui utility but supports fewer features. Let's understand some important differences between Nmt Ui and Nmconnection Editor. Nmt Ui is a curses-based application. It does not need a GUI environment to run. You can use it on CLI and GUI. It supports all necessary features of Network Manager. You can use it to add new connections, manage existing connections, activate a connection, and change the host name. Nmconnection Editor is a GTK-based application. It needs a GUI environment to run. You can use it only on GUI. It supports only essential features of Network Manager. You can use it to add new connections and manage existing connections. You can't use it to activate a connection or change the host name. To add a new connection, click the Add button. The utility supports many types of network devices. You can create a connection for any supported device but can use the connection only if that device is available on the system. This system has an Ethernet card. Let's select Ethernet from the list and click Create. The next screen allows us to customize the connection. It has many options. Options are organized in tabs. Let's understand the options you need to know for RHCSA or RHCE Exam. This is the connection name. Network Manager and other services will use this name to list and use this connection. On the General tab, we have two important options. These options are the connect automatically with priority and all users may connect to this network. Let's understand these options in detail. You can create multiple connections for a device but can use only one connection at a time. If you select this option on all connections, Network Manager will automatically pick and use the appropriate connection to connect the network. For example, suppose you use your laptop at the office and the home. Both places have Wi-Fi networks. In that case, you can create two connections, one for the home Wi-Fi network and another for the office Wi-Fi network. If you select this option on both connections, Network Manager will automatically select the appropriate connection based on your location. If you use the laptop at the home, it will use the connection you created for the home Wi-Fi network. Or if you use the laptop at the office, it will use the connection you created for the office Wi-Fi network. If you have multiple Wi-Fi networks at the home or office, you can create multiple connections for that location. If you have multiple connections for a single location, you can use the priority option to decide the order in which Network Manager should use the connections. Network Manager picks the connection with the highest priority. If the highest priority connection is not available, then it selects the second highest priority connection, and so on. In the lab environment, we don't need to configure this option. Uncheck this option. If you select this option, all users can use this connection to connect to the network. If you uncheck this option, only you can use this connection to connect the network. Keep this option selected. As I mentioned earlier, you can create a connection for any supported device but can use the connection only if that device exists on the system. We are creating a connection for an Ethernet device. We can use this connection only if we assign it to a physical Ethernet device. Select the Ethernet device from the drop-down. To use a connection to connect the network, we need to assign an IP configuration to it. Select the manual method. The manual method allows us to configure an IP address manually. If you want this connection to obtain an IP address from a DHCP server, select DHCP. Now, let's assign an IP configuration to it. We don't need to configure any other option. Let's save the connection. Network Manager saves all configurations of a connection in the connection configuration file. It saves all connection files in Network Scripts directory. It uses the connection name as the file name with the FCFG prefix. To verify the settings you made, you can check the connection configuration file. To verify the connection, you can use the Nmcli connection show command. As I mentioned earlier, a device can have multiple connections but can use only the active connection. You can set only one connection active at a time. Nmconnection Editor does not have an option to activate the connection. You can use the Nmconnection Editor only to create, manage, and delete a connection. To activate a connection, you can use the Nmcli command or Nmt Ui Utility. Let's use the Nmcli command to activate the connection. After activating the connection, you can use the IP address show command to view the IP configuration of the interface. As we can see here, the interface is using the IP configuration from the new connection. To edit a connection, start the Nmconnection Editor utility. Select the connection you want to edit and click the Edit button. From here, we can update all settings. Let's change the IP address and click Save. Network Manager does not actively monitor connection configuration files. If you make any change in the connection configuration file, you need to force Network Manager to reread the connection file. As we can see here, even though we have updated the configuration file, the interface is still using the old IP address. To force Network Manager to reread the connection configuration file, you can use the Nmcli connection command. We use the down option to deactivate the connection. To activate it again, we use the up option. Now, let's use the IP address show command again to verify the change. As we can see, now the device is using the new configuration. To delete or remove a connection, start Nmconnection Editor. Select the connection you want to delete and click the Delete button. Confirm the delete operation. To verify that the connection has been deleted, we can list all connections again. As we can see here, the connection has been deleted. The Network Settings tool and the network icon are part of the GNOME desktop package. They are available only on the desktop. They support all essential features of Network Manager. You can use them to view, add, and manage connections. This is the network icon. It displays the current status of the active connection. As you can see here, this system is connected to the network. If there is no active connection or the system is not connected to the network, you will not see this icon. From here, you can disconnect or connect the interface. If you want to manage a connection, you can open the Network Settings tool directly from here. If the network icon is not available, you can also open the Network Settings tool from the menu. Click Activates. Search Network. Click Network. GNOME opens all settings in a new window. Click Network in the left pane. From the right pane, we can manage connections. We can add a new connection from here. Set connection name. Set IP4 configuration. Click Add to save this connection. To manage an existing connection, click the gear icon of the connection. From here, you can manage the essential settings of the connection. You can remove this connection. You can change the IP configuration of the connection. You can also update the method the interface should use to obtain the IP address. After making changes, click Apply to save changes. As I mentioned earlier, the Network Settings tool and the Network Connection icon are part of the GNOME desktop package. They do not directly make changes in configuration files. They update configuration files through the Network Manager's API. It means you can use these tools only if the Network Manager service is running. To verify the changes, we can list all connections. This is the connection that we added through the Network Setting tool. Let's activate it. List the connections again to verify the change. As we can see here, now the interface is using the connection we added through the Network Setting tool. We can delete this connection directly from the command line or can use the Network Setting tool. Let's use the Network Setting tool to delete this connection. Before we delete this connection, let's activate the default connection. Click the gear icon. Click Remove Connection Profile. Close the Network Setting tool. To verify the delete operation, we can list all connections again. We can also list the network scripts directory. As we can see here, the connection that was added through the Network Setting tool has been deleted. We can also use the IP address command to verify the default connection. That's all for this video. In this video, we learned how to view, list and manage IP addresses on Linux. We also learned what the Network Manager is and how to use its default tools to manage IP addresses. If you have any comments, suggestions, or feedback about this video, please share them in the comment section given below.